Hello Year 9, this is your lesson on reasoning with angles. So we can use the results from last lesson in a variety of situations. Here's our first example. So we want to find the angle AOB, so that's this indicated one here, in terms of theta, which we can see is this angle up here, and we need to give reasons. So firstly, I can see that these two angles here are equal because they are corresponding. So I can say that angle AOF equals theta because it's corresponding. Then angle AOF and angle AOB are supplementary because they're on a straight line. So angle AOF plus angle AOB equals 180. So I can substitute theta in for AOF. Theta plus angle AOB equals 180. Then I can subtract theta from each side, and angle AOB equals 180 minus theta. In our second example here, I have an isosceles triangle. Now remember, in an isosceles triangle, base angles are equal. So the angle AOC, this one here, is going to be equal to 180 subtract theta divided by 2. Now if I've gone a bit quickly for you there, let's call both of these x. So if I wanted to know what this angle x here is, I've got x plus theta equals 180. They're the three angles in my triangle. So 2x plus theta is 180. Subtract theta from both sides. And I just want one x, and I've currently got 2, so x equals 180 minus theta over 2. I can simplify this. 180 divided by 2 is 90, and I'm going to just leave this as a fraction, theta over 2. Now, angle AOC and angle AOB make up a straight line. So AOC plus angle AOB equal 180. And so angle AOC, remember from here, I've got 90 minus theta over 2 plus angle AOB equals 180. I subtract this from both sides. So angle AOB is 180 minus, I'm going to put it in brackets so I don't make mistakes with the positives and negatives. So this is like saying 180 minus 90, which is 90. Then I'm subtracting negative theta over 2, so that's plus theta over 2. Pause the video now while you have a go at these questions. Okay, in this diagram, we've got this kind of zigzag shape, and I need to show that alpha plus beta equals 90. Now you'll see this looks a bit strange. Again, in this section of the book, there's lots of little degree symbols in the place of some of these Greek letters. So just be careful about understanding it. I've replaced them all on this presentation. So to be able to do this, I'm going to introduce a new line here, XO, which is parallel to AF and parallel to BG. Now from this, I can say that angle FAO is equal to angle AOX. That's these two, because they are alternate angles in parallel lines. So I can say that angle AOX equals alpha. Angle XOB is equal to angle OBG. I could just say ditto here because it's the same reason as before. They're alternate angles in these parallel lines. So angle XOB equals beta. Now I can see here that this angle is a right angle, so I can say, therefore, remember I can fill things in, so this is alpha, this is beta, alpha plus beta equals 90 degrees. Pause the video while you have a go at these questions. This symbol here means perpendicular, which is at right angles to. Okay, so here I've got another similar question where I've got a kind of zigzag going on, and to make the question easier, I've introduced a third parallel line. So here I can say that angle XCD equals gamma. Here and here we've got parallel lines, we've got the transversal here, CD, and these are on alternate sides of my transversal. Here, angle BCX plus alpha equals 180 degrees. So here and here, because they're co-interior. Remember, co-interior angles are supplementary. So I can say that angle BCX is 180 subtract alpha. Now angle beta is angle BCX plus XCD. So that's XCD is gamma plus BCX, which is 180 minus alpha. Now I want to get all of the pronumerals on one side, so I'm going to need to subtract the gamma and add the alpha. So alpha plus beta minus gamma equals 180 degrees. And that's what I was asked for. Pause the video while you have a go at these two questions. These three parts of the question, sorry. Okay, so the results that we've looked at can be used to prove many interesting general results called theorems. I'll let you read that information there. Okay, so here, these are our italics, so that's the theorem that we're trying to prove. A quadrilateral with two pairs of equal adjacent angles is a trapezium. So equal means equal, adjacent, remember, means next to. So here I've got two angles next to each other that are equal, and another two angles next to each other that are equal. I'm given that information in the statement, and I'm given that information in the diagram as well. For my first step, I need to prove that alpha plus beta equals 180. Now here, I have a quadrilateral. So alpha plus beta, that's the four angles of my quadrilateral. They add up to 360 degrees. I can simplify this side by collecting like terms. 2 alpha plus 2 beta is 360. Now I have a common term of 2 in each of my parts, so I can divide everything by 2. Alpha plus beta equals 180. So that's part A done. Part B, hence prove that this is a trapezium. Now, as alpha plus beta equals 180, alpha and beta are co-interior angles. So we can say that alpha and beta are supplementary, because they add up to 180, and co-interior. And if you remember back to proving that two lines are parallel, if we've got co-interior angles that are supplementary, then that must mean, therefore, AD is parallel to BC. AD is parallel to BC, and BA in this case is our transversal. Okay, so pause the video while you have a go at questions 4, 5, 6. Now, we're going to have a look at interior angles of polygons. A polygon, remember, is a 2D straight-edged shape. So we've got no curves on the edges here. Poly just means many, gon means sides. So these are our polygons. Let's just have a quick check that we know what their names are. A four-sided polygon is called a quadrilateral. A five-sided polygon, pentagon. 6 sides, hexagon. 7, heptagon or septagon are acceptable. Now, our quadrilateral, we can chop it up into 2 triangles. Each triangle, we know how many angles are in a triangle, how many degrees are in a triangle? 180. So a quadrilateral has 2 times 180, which is 360 degrees. We looked at that one last lesson. How about a pentagon though? What we can do is chop a pentagon up into 3 triangles. Each of those triangles has got 180 degrees in it. So a pentagon, its interior angles add up to 3 times 180, which is 540. Hexagon, here we can see it's split up into 4 triangles. So the sum of the interior angles of a hexagon is 4 times 180, which is 720. 7-sided heptagon, 5 triangles. So the interior angles of a heptagon add up to 5 times 180, which is 900 degrees. Now, the 4-sided polygon can be split up into 2 triangles. 5-sided polygon, 3 triangles. 6-sided polygon, 4 triangles. 7-sided polygon, 5 triangles. So the connection between the number of sides, the number of triangles, there are 2 fewer triangles than sides. So we can work out the sum of the interior angles of a polygon by taking the number of sides and subtracting 2, and then multiplying that by 180. So use that information to help you with question 7. If you have any questions, ask your teacher. Thank you very much.